Technology permeates our daily lives. It is always important to think about what technology should do instead of what it can do. I'm Richard Koh, and welcome to our Tech 101 with our technology strategist. Hi everyone, welcome to this episode of Tech 101 with our tech strategist here at Microsoft again. Today on the show, I have guest Yong Keat, who has joined us as an intern 2 years ago and now full-time here at Microsoft. So welcome to the show, Yong Keat.
Hi Richard, Good. Happy to be on this show.
That's great. So tell us a little bit what you do on a day-to-day basis.
Yeah, so I'm an account technology strategist here at Microsoft. I take care of our education customers, and from a day-to-day I basically help them with their technology strategy, their road mapping, envisioning some of the possible use cases that they can do with our various services and technology. And I think really bringing in also the industry thought leadership, right, as to how Microsoft can value add to their education transformation journey.
Okay, that's really great. Really empowering our next generation of leaders and even educators themselves, to think about how they can leverage technology. So I heard that today you are bringing a topic around knowledge mining, especially on our cloud platform using Azure itself, for organization a way to think about how they can query their data. So tell us a little bit more about knowledge mining and why would organization be interested in doing something like this?
Yeah, so knowledge mining is definitely a really up and coming topic. As you know, there's a lot of advancements in technology and we're kind of moving into a more and more digital age. That means that you are generating troves and troves of data. And having all the data sit somewhere in your on-premise or in some form of storage, how do you then kind of maximize the use of this data? We are talking about terabytes and petabytes of data that's coming in from all the different telemetries and all the different data sources you're collecting. So how do you then be able to generate insights, move from just a reactive kind of reason to use data to more proactive? And these insights will then help you drive your business outcomes, right, and objectives. And of course, you want to be able to discover the latent insights that are sitting inside all the data that you're collecting, and hence be able to bring it to help you discover what more you can do for your organization.
Okay, that's very cool. And you know what? I was just thinking about the term data that you were using. Just in the moment that we're speaking, the whole entire world probably generates more data in this moment than perhaps in a day in year 2000 itself. Now, you talked about this point around latent insights, which is very key. I think a lot of times organizations has many forms of data, structured, unstructured, and the relationship amongst these data. Tell me a little bit more about that.
You rightly called out the structured, unstructured data. So I think structured data has always been out there, in the form of like your SQL databases or your Excel sheet. So really talking more about unstructured data is things like your PDF, your PowerPoints, even like maybe online websites or various kinds of unstructured data that doesn't necessarily form like tabular format or whatsoever, right? So all this information, you want to be able to mine the information, the insights out of this various unstructured data, and it's not something that can be easily done, through conventional means. But with the advancements in technology over in AI, so we have things like our cognitive skills and services, which then kind of act like human understanding, take in the human side of things, right? In a PDF file, you can be able to extract images and kind of even have a description about what about inside the images that they contain and have about.
Okay, so this is really cool. We're applying the AI technologies into the data that has been gathered and then be able to apply that to really discern what those data represents, right?
Yeah,
okay,
exactly.
Very cool. So I heard you got a very exciting demo for us around knowledge mining. So shall we go catch the demo?
Yeah, sure, definitely. I think there's a lot to knowledge mining, and what we have in terms of Azure Search. It is all the way starting from ingesting some of our information, doing document cracking. So it's a really interesting concept, and yeah, I'm more than happy to get onto this demo.
Okay, very cool. This sounds very exciting. Looking forward to seeing it. All right, folks, let's go.
In this demo, I will show you how you can easily use the Azure portal to create your first Azure Cognitive Search Index without writing any code. In the next few minutes, I will show you how to ingest a set of files, extract unstructured content from these files, index this content, and learn how to query your new index. First, let us create an Azure search resource. In the Azure portal, look for cognitive search and key in the required information such as resource group, location, and pricing tier. Then let us create an Azure Cognitive Services resource. This will be needed when Azure Search carries out AI enrichment to our ingested documents. Similarly, look for cognitive services and key in the required information such as resource group, location, and pricing tier. With that, we are ready to start using cognitive search. Over here, I have an existing storage account and container containing clinical trial documents in PDF format. To briefly show you how it looks like, I am downloading and opening one for you. As you can see, it contains details about the clinical study, such as a brief excerpt, tests, and procedures. Now enter the cognitive search service that was created. In the next few steps, we will be setting up the object model for our search. The data source defines information about the source of the data, type of data source, how to read it, credentials, etc. The skill set defines any enrichment steps or skills that you apply to your data. The index defines the shape of the searchable index. And finally, these three objects are connected by an indexer that orchestrates the ingestion of data from the data source, execution of the skill set, and how to map the enriched data into the index. Let us start by importing the clinical trials data that I have just shown. I can select from a range of data storage services such as Cosmos DB, Blob Storage, Azure Data Lake, or even SharePoint Online, which is currently in preview mode. Choose Blob Storage and indicate the data source that contained our clinical trial documents. This second tab allows for extraction and enrichment steps, also known as cognitive skills, which are combined into a skill set referenced during indexing. We can use built-in cognitive skills such as cognitive services or custom skills. With cognitive services attached, we can now use text cognitive skills to extract people, organization and location names, and image cognitive skills to generate text, captions, or celebrities. You can automate all of this out of the box with a few clicks of button. In this step, you are designing your Azure Cognitive Search Index. This is an important and powerful part of the index build process as you select the types of analyzer you want to use and make determinations of features such as which fields and data will be retrievable, filterable, sortable, and searchable. Finally, let us create an indexer to string all the parts together. At the execution history, it will show how long it took and the number of documents processed. Now that the content has been indexed, we can use the portal to test some search queries. In the Search Explorer, a search query such as MPS will allow us to find all documents that refer to the disease MPS. Let's try to search for Goucher. As you can see, the English Microsoft Analyzer was able to pick up variations to this phrase, such as Goucher and Gouchers. By adding a parameter, highlight equals content, it picks up the paragraph containing the keyword Goucher. The count parameter shows us that there is a total of 8 references. Earlier we mentioned about custom skills as opposed to built-in skills. Building a custom skill gives you a way to insert transformations unique to your content. A custom skill executes independently, applying whatever enrichment step you require and allowing you to develop extremely powerful and domain-specific knowledge mining solutions. Over here, we have a repository of example power skills that developers can adapt for use. In healthcare, there could be medical terms that are not found in the layman dictionary. A new custom skill will identify and extract disease names from the dataset and store them as entities in a separate field attached to the document. By doing so, it will allow us to leverage capabilities such as leveraging facets to show diseases and their counts that are mentioned in the corpus of search results, and filtering documents that refer to a specific disease. In this example, I am using custom entity lookup skill from the Power Skills repository. We can place our own dictionary of disease names into this file called words.csv. Given a user-defined list of entities, this skill function will find all occurrences of the entity in some input text. Using Postman and a local endpoint, I am doing a quick test of my Azure function so that it is producing the right output entities. As we can see, given the text input, the function returns a list of medical diseases found. Now that we have a working Azure function, we will deploy it to Azure by publishing our solution onto an Azure Functions consumption plan. Once published, we can head over to Azure Portal and obtain the function URL from the published Azure function. With our working custom skill, we now need to update the object model. First, an additional field needs to be added into the index schema, which we call diseases collection. We define index parameters for this field, such as searchable, retrievable, etc. Second, we need to update our skills definition to add an additional skill for custom entity lookup by providing information such as URL, HTTP method, input source, and output targets. Lastly, with our indexer definition, we map the correct document output from our newly added skill to the newly added field name in our index. Over here, we are aggregating all the identified diseases names from our skill set into a single list and pushing that into a field called diseases collection. Once the indexer is refreshed, we can enter a research query as such. This query here allows us to filter documents by the molecule disease and showing us all found diseases and title of these documents. In addition to custom skills, you can also add custom analyzers. An analyzer is a component of the full text search engine that's responsible for processing strings during indexing and query execution. Let's modify the index like we did in the previous module to add a new field called diseases phonetic, which makes use of the phonetic custom analyzer. To do so, we'll make a put request to update the index. Notice that the field uses an analyzer called myPhonetic. This will be the custom analyzer that we will need to create. Under the analyzers list, we will add a custom analyzer and also a token filter. And although not shown here, we'll also need to update the respective output field mapping in the indexer. If successful, we should receive a 204 no content response. We then reset and run the indexer again. Now with the new phonetic analyzer, we test on both the right and wrongly spelled word mucopolysaccharidosis. In this first query, the right spelling is provided and it returns the token MKPL. In the second query, the wrong spelling is provided, but it also returns the same token MKPL. This allows users to get their intended search results despite an incorrect spelling but phonetically similar word. Lastly, you can also configure your scoring profiles to determine what are the most relevant documents to send back. This is primarily based on an algorithm called TF/IDF. Apart from all that has been touched upon, the Cognitive Search Accelerator also provides a front-end web interface for you, so you do not have to build one from scratch. In this case, I can facet by location or diseases collection. Over here, I choose United States and Molecule. By clicking into a search result, I open a PDF's content and also see its associated text. I can then select on the tag to lead me into the section containing the tag. The Metadata tab shows you the different fields that were defined in the index schema. Next, we enter the entity map. By including diseases as facets, I can see that the disease might be related to Mokyo. An instance seen here is mucopolysaccharidosis. If I click on mucopolysaccharidosis, I can now make it the new subject of the entity map for further analysis or investigation. Cognitive search has extensive use cases. One could be for purposes of research and investigation of a historical event and corresponding materials. In 2017, more than 34,000 pages related to the JFK assassination were released. It will take researchers months to read through this volume of documents. How can we take in all this information and any new information that is released? We can combine Azure Search and cognitive services together to create a solution to these problems, an AI-first approach to content understanding. A user can search through materials related to Oswald, which includes print, handwritten notes, and even photographs. With the power of computer vision, we can generate captions and identify faces. We also notice that GPU flaw was highlighted. This is not a typo, and is actually a CIA cryptonym for Lee Harvey Oswald. This annotation was created by a custom queue using a list of published code words that you can find on the internet. By running at the entity map, I can also see that what are the other closely related entities to Oswald, such as Sylvia Duran. Another example here is the legal industry. Walter's Clue empowers attorneys to more quickly find the information they need. This is especially important because the time of an attorney is precious. In this specific example, the WK processed securities and exchange commission filings and correspondence between public companies and the SEC. The first challenge that WK faced here is that SEC filings come in different flavors and formats. For instance, let me search for a company. Let's actually search for Microsoft. As we can see, cognitive search allowed WK to ingest files of different types, such as slides and PDFs. It was really nice that this happened automatically for us. Cognitive search just understood how to ingest the different file types. Note that as part of the enrichment pipeline, we are doing automatic key phrase extraction and also identifying entities of importance, such as people, places, and organizations. The green tags are key phrases that were automatically extracted thanks to their built-in cognitive skills. The blue tags are named entities, such as organizations, locations, and places that were extracted. Cognitive search allows us to integrate custom machine learning models as part of the enrichment pipeline. Notice the right pane that shows the sender and recipient and the company that it came from. Once this information was extracted, it was then used by the application to automatically generate threads of letters the SEC sent to companies. Here we can see 4 letters that were sent by Robert to Roger. These threads will help my attorney learn from these communications to improve the way in which they create their filings. Another custom classification model was created to identify the risk category, such as cybersecurity. This model was created using AML text analytics using labeled documents. It was then integrated into the cognitive search pipeline. Thus, this allows for meaningful facets to be created and improving the search needs of attorneys.
Wow, Yong Keat, that was a really cool demo. I mean, you just show in a short amount of time, any organizations can leverage these tools in Azure to be able to ingest the data, build this knowledge tree that you can query against, and like you said, discover some of the latent insights between the relationships of all these disparate pieces of data. Now, tell me a little bit about how organizations should think about this. What kind of use cases would they be interested in applying these capabilities to?
Yeah, so for instance, one of our customers at Howden, what they have done, what Howden does is they do manufacturing, and they basically build like compressors, exchanges, and they're part of doing mechanical engineering. So when they actually bid for projects, they have to crawl through a lot of information, and what that means is, they have to read like many pieces of documents that comes in the form of diagrams or even huge manuals, right? What using Azure Search has done for them is really cut this time by a significant amount. allow them to identify some of the risk they have when they're reading through these manuals and some of these requirement specifications, and allow them to bid in the most cost-effective manner, right? And hence put them in a competitive position. And hence, this is really kind of helping them drive a more attractive bid, to our customers, not something that is overpriced or underpriced. So this is one way that one of our customers have used it. And I think secondly, also kind of bringing more into the medical context, right? So especially when patients come in, the front desk starts the triaging. The doctors and nurses needs like various information to be able to have that 360 view of the customer. So I think a lot of information in the health context comes from our health records, but they might be coming from different sources, from your past medical records, or from some other visits that you might have. In a sense, being able to query all this together and apply like special AI enrichment that allows you to identify specific medical terms. So as you know, medical terms is something that is much more contextualized and not necessarily part of our dictionary. And hence this enables like the doctors and nurses be able to identify what are some of the key things that they should look out for when they are like basically giving treatment to the patients. So I think that basically drives the efficiency. It allows our customers to do what they should be focusing on most, right? Which is to attend to the patient and basically give the care and treatment that they should have, instead of wasting a lot of time having to comb through all this information.
And that's really cool. It's really technology, and intelligent technology, empowering these organizations, the users themselves, to be able to achieve more and really focus on the core work itself, right? Yeah, so that's great. And at Microsoft, we are always looking out to create tools and platforms to help accelerate our customers in terms of the way they learn about these tools and quickly get up to speed and benefit from these kind of technologies. Tell me a little bit more about what we might be doing in this space.
Yeah, exactly right. So Azure Search is actually, first thing, is a platform as a service. So what that means is you no longer have to build this whole pipeline and this whole software on your own. So it actually allows you to just tap on platform as a service and allow you to ingest and allow you to create all this AI enrichment through some of our inbuilt cognitive services as well. So that will really kind of take time off your shoulders and your developers and your IT, right? Having to manage and build this platform. So I think also, on top of that, also secondly is having what we call like a knowledge mining solution accelerator. So that will actually allow you to be able to just take something off what we have built on GitHub as an open source repository, and that will then, you don't have to basically build the whole configuration on your own, but you can just quickly get off your feet, and be able to test it out yourself without too much effort.
Okay, wow, that is really cool. So I'm sure our audience is going to be very excited to get their hands, dirty in trying these out. So if they want to learn about where to go and find out more information, where should they go?
Well, you can visit the link below here and find out more about how we can get started.
Okay, well, Yong Keat, thank you for being on the show. That has been really insightful for sharing around the capabilities on knowledge mining on Azure itself. And folks, I hope you take the time to explore this very important topic, especially when your organization is dealing with a lot of disparate data in many different silos and trying to make sense of it. I think this is a very exciting progression of the intelligent technology that we provide on Azure. So hopefully I've gained some insights from this, and I will see you at the next episode. Thank you very much.